Math 83, Unit 4, Lesson 1. We want to determine whether a monomial is a factor of a polynomial. And we want to know which of the following are factors of 100, a to the third, b to the fourth, c. Well, first we're going to take the number 100 and we're going to break it down to its product of primes. And we do that with a factor tree. So 100 is 10 times 10. And then we can break down each of these 10s to be 2 times 5, and this one's 2 times 5. So 100 is 2 times 2 times 5 times 5. And then we're going to expand out the a to the third to be a times a times a, b to the fourth to be b times b times b times b, and then we have a c. And all of those are being multiplied together. Now we're going to look to see if 10 a squared b to the fourth c is inside of this monomial. Well, 10 would be this 2 times 5, a squared would be a times a, b to the fourth would be all of these, b times b times b times b, and then a c. So yes, indeed, this is a factor because it is inside of 100 a cubed b to the fourth c. Now we're going to check to see if 5 a to the fourth b to the fourth c is inside of this monomial. Well, 5 I've got right here. A to the fourth, well, I only have a to the third. I don't have an a to the fourth, so this power is too big. So no, this is not a factor. Now I'm going to check 50 a, b, c. So 50, I could make 50 by doing 5 times 5 times 2. So that would be right here. 5 times 5 times 2, that would be 50. And then I have an A, I have a B, and I have a C. So yes, this is inside of 100 a cubed b to the fourth c. Now let's check to see if 20 a cubed b is inside the monomial. I can make 20 with 2 times 2 times 5. 2 times 2 is 4, times 5 is 20, so that's inside. A to the third is right here. And then I have a b, so yes, this is a factor. Now we're going to check to see if 25ac squared is a factor. I can make 25 with 5 times 5, and then I have an a, so that's inside, and then c squared. Uh-oh, we only have a c. C squared is too big, so no, this is not a factor. Now we'll check to see if 200 abc is a factor. 200, well, 2 times 2 times 5 times 5, that's only 100. So 200 is too big, so that is not a factor. Now we'll check to see if 2a squared b to the fourth c is a factor. Well, I have a 2 here, so that's inside. I have an a squared, I have a b to the fourth, and I have a c. So yes, this is a factor. Now we're going to see if 100 a to the third b to the fourth c is a factor. Well, to make 100, I can do 2 times 2 times 5 times 5. It's right in there. A to the third, I have that there. B to the fourth is there. And c is there. So yes, this is a factor. Number 2, which of the following are factors of 33, x, y to the 7th, z to the 5th? So let's expand it out. 33 is 3 times 11, and then we have an x, y to the 7th, so 1, 2, 3, 4, 5, 6, 7, and then z to the 5th, 1, 2, 3, 4, 5. And we're going to check to see if the following are factors. Now I want you to go ahead and try this on your own and come back and check your answers. Okay, so check your answers now. The ones that are not factors, 3x squared is not a factor because x squared is too big. We only have an x inside. And then over here, 2xyz is not a factor because there's no 2 inside of 33. And then in h, 33x y to the 8th, z to the 3rd, y to the 8th, we only have a y to the 7th, so y to the 8th is too big. The rest are factors. Now we're going to find the greatest common factor, which is also called the GCF, given a set of monomials. So we're going to try to find the greatest common factor of these three monomials. Well, let's just look at the number part first. 110, 30, and 60. So what's the biggest number that goes into all three of those numbers? And that's 10. And then we're going to look at the variables x squared, x to the 7th, and x to the 8th. Well, x squared is inside of x to the 7th and x to the 8th. So that's going to be our greatest common factor, 10x to the 2nd. Now in number 4, we're trying to find the GCF of these three monomials. And we're going to look for a number that goes into negative 18, 3, and 9. And then we're looking for the biggest number that goes into all three, or the greatest, and that would be 3. Now let's look at the variable a. We have a to the 4th, another a to the 4th, and then an a to the 3rd. So of those three, there's an a to the 3rd in all of them. And then we have a b in the first one, and then we have no b in the second monomial, and then a b in the third. Because b is not in the second one, it can't be a factor of that particular monomial. So 3a cubed is our greatest common factor. So looking at number 5, we're going to find the greatest common factor of these three monomials. Looking at the number part, negative 30, 15, and 60, the biggest number that goes into all three of them is 15. And then we have an x squared, an x cubed, and an x cubed. So the smallest of the three is x squared. So x squared is inside of all of them. And then we have a y to the 4th, and a y to the 3rd. And so there's a y inside of all of those three monomials. So 15x squared y is our greatest common factor. Number 3, we're going to factor out the greatest common factor, or GCF, from a polynomial. But before we do that, we have to review how we multiply a monomial, like 2x, times a polynomial. So let's say we have x squared plus 3x plus 2. So when we use the distributive rule, we would take 2x and multiply it by each term inside of the parentheses, and we would get 2x cubed. Here we would add the exponents. Then 2 times 3 is 6, x times x is x squared, and then 2x times 2 is going to be 4x. And so we multiplied and we used the distributive rule. So when we factor out the greatest common factor, we're just going the other direction. I'm going to give you the answer here, and you're going to come back and tell me what it looked like before. So you're going to factor out the greatest common factor. So we're going to look at each term. In number 6, we have 3y and 27, and we want to find what's the biggest number that goes into both 3 and 27, and that's 3. I have a variable of y in the first term, but I don't have a y in the second term, so I can't pull that out of there. So the greatest common factor being 3, I'll put my parentheses, and I think 3 times what is going to give me 3y. Well, 3 times y is 3y, and then 3 times 9 is 27. And so if I were to multiply this back out using the distributive rule, I'd get 3y plus 27 back. So between these two terms, there's no number I can pull out of 9 and 8. They don't have any common factor other than 1. But between m squared and m cubed, I can pull out an m squared. And so that would be the greatest common factor. So let's see what would be inside the parentheses. M squared times 9 is going to be 9m squared. And then we have a minus. And then 8, and we need another m here because m squared times m gives me m to the 3rd. In number 8, we want to pull out the greatest common factor. So between 15 and 25, 5 is the biggest number I can take out. And then for the variable, we have an x squared and an x, so I can take an x out of each term. And 5x times what is 15x squared? Well, that's going to be a 3x. Because 5 times 3 is 15, and x times x is x squared. And then we're going to need a 5 here, so 5x times 5 is going to be 25x. In number 9, between 8 and 5, there's no number that they have in common that I can pull out other than 1. There's no x in both terms, so I can't take an x out, but I can take a y out. So that's our greatest common factor. Let's see what we have left. Y times 8y is going to give us an 8y squared. And over here, we need a 5, and we need an x squared, but we already have a y. So 5x squared times this y is going to give us our 5x squared y back. In number 10, the biggest number that goes into 4 and into 8 is going to be 4. And then for our variables, we have x cubed in both of them, so we can take out an x cubed. And then we have a y and a y to the 4th, so I can take out a y. And 4x cubed y times what is going to give us 4x cubed y? Well, we need to have a 1 here, so we can multiply it by 1 to get it back. Minus, and then 4 times 2 is 8. We already have the x cubed. And then we need a y cubed. So if we were to multiply that back out, we would get 4x cubed y minus 8x cubed y to the 4th. Number 11, we can pull out a 9 out of every term. And the 45 doesn't have an x, so I can't pull an x out of every single term. So what do we have left? Well, we have an x to the 6 plus an x. And then 9 times 5 is 45. We can pull out of all of these, there's no number I can take out of each, but b squared is the greatest common factor I can take out, and we'd be left with 7b squared minus 4b, b squared times b, and then plus 1, because we need b squared times 1 to give us this term back. The greatest common factor would be 2x. You can take a 2 out of 2, 4, and 8, and all the terms have an x, so I can pull that out. And I'm left with x squared, because x times x squared is x cubed. And then 2 times 2 is 4, and I need another x here, so x times x is x squared. And then 2x times 4 is going to give me 8x. Number 14, we want to know which of the following is an equivalent expression to 20x to the 6th plus 12x to the 4th plus 28x squared. And the way to do that is to just go ahead and multiply these out and see which one is equivalent. So in A, we're going to multiply 2 by every term and get 20x to the 6th plus 12x to the 4th plus 28x. Well, we have a 28x here, and we have a 28x squared in the original expression. So this one is not it. Now we're going to go ahead and multiply in B 2x by every term, and we're going to get 20x to the 6th. Here we're going to add the exponents of x and x to the 5th. And then 2 times 6 is 12. Adding those exponents, I get x to the 4th. And then 2x times 14 is going to be 28x. And again, in this one, 28x is not the same as 28x squared here. So this one is not it either. Now we're going to take a look at C. And when we multiply C out, we're going to get 20x to the 4th by adding those exponents. Then we're going to get 12x to the 3rd. And then we're going to get 28x here. And again, here's the problem. Well, we've got more than one problem. Here is also a problem. There's this one's x to the 4th, and this is x to the 3rd. And actually here also, x to the 6th, x to the 4th. So that one is not it. So in D, when we multiply 2x squared by every term, we're going to get 20x to the 6th, and then we're going to get 12x to the 4th, and then we're going to get 28x squared Well, now this one is exactly the same thing as this expression up here. So D must be our answer. It's always good to go ahead and do the next one just to make sure that it's not it and we didn't miss something. So 2x cubed times 10x cubed would be 20x to the 6th. And then we'd get 12x to the 4th. And then we'd get 28x to the 3rd. So this one's definitely not it either because we have an x to the 3rd here. So D is our answer. In number 15, we want to know which of the following is not an equivalent expression. So here we're going to have to check each one until we find one that is not the same. So in A, we're going to go ahead and multiply that out, and we're going to get 12, a to the 3rd, b to the 2nd, and then 4a squared b squared minus 24ab. Well, that one is exactly the same. So this one is equivalent. In B, we're going to get 4 times 3 is 12. A times a squared is going to be a to the 3rd, and then we have the b squared. The next term, we'll have 4, and then a times a is a squared. And then we have b squared minus 4 times 6 is 24, and then we have an ab. So this one turns out to be an equivalent expression, so it's not that one. Let's check C. 4 times 3 is going to give me 12, a cubed, and then b times b is b squared. And then we have a 4, a squared, and then our b times b is b squared. And then 4 times 6 is 24, ab. So it turns out this one is equivalent as well. Let's check D. 4 times 3 is 12. A times a squared is a cubed. B times b is b squared. Next term, we have 4, a times a is a squared, b times b is b squared, minus, and then 4 times 6 is 24, and then we have an ab. So it turns out this one is also equivalent. So let's go take a look at E. We think right now that that one is not, since all the other ones are, but let's double check. 4 times 3 is 12. A times a squared is a cubed. B times b squared is b cubed. Well, right there we can see that's a problem because we only have a b squared on this term. Just go ahead and finish multiplying this out. We have 4, a times a is a squared, b times b is b squared, minus 4 times 6 is 24, and then we have an a squared b. So here also we have a different term over here. So E is definitely not equivalent.